Hello and welcome to our first section about Docker and Kubernetes. For the first topic, I choose Docker Introduction. My name is Hamed Mehdizadeh and I'm Linux and DevOps engineer. Why containers? In the dark ages, we need to know there was one physical server, one operating system like Linux and Windows Server, and of course, an application were installed on top of them. After that age, we just introduced to hypervisor-based virtualization. One physical server can contain multiple applications. Each application runs in a virtual machine. So we just had one physical server, one bare metal already installed hypervisor like ES6 from VMware Group. And of course, there was a headache and for installing each guest operating system, installing dependencies for the application, each applications, and make these applications to work with each other. We need to know about application modernization. There was some issues for developers, like minor code changes require full recompile and retest. Application becomes single point of failure and application is difficult to scale. But with microservices, break application into separate operations. These applications can run in separate containers to speed up the service and for high availability, for fault tolerance, and make applications independently scalable, stateless, highly available by design. You can see in here the architecture about microservices and monolithic architecture. There, in the monolithic architecture, there was just one single instance for all of those services. But in the microservices, we can separate these services from each other and run them in their own cluster and their own containers. What is container? A container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. Applications are safer in containers, and Docker provides the strongest default isolation capabilities in the industry. So there is a standard packaging for software and dependencies, isolate apps from each other, share the same OS kernel, and works with all major Linux and Windows servers. So as you can see in here, there is 3 containers already running on the same kernel, same OS, and there is no overhead for CPU, there is no overhead for RAM. And each application like Tomcat SQL Server has its own dependencies, OS, dependencies, and of course the application. So it's run faster because there is no each application, each container runs faster because there is no OS to boot up. We need to compare containers with VMs. So we just already talked about this. There was one infrastructure, host operating system, or one hypervisor already bare metal installed on the infrastructure, and of course installing guest OS, installing dependencies for application, and application run on top of them. But in the containers, we just had one infrastructure, one operating system, one container engine like Docker, and of course each of these apps has its own dependencies in a container and they are isolated and separate from each other. They can scale up for high availability and for fault tolerance. So there is no overhead for guest OS. There is no overhead for hypervisor. Containers and VMs together in the development environment. We need to know about the physical. We just had one physical server, one operating system, and Docker engine, and of course running the application on its own container for development environment. And for production environment, we had one physical server, hypervisor, and of course we can separate all of these Docker engines and clusters from each other with VMs. And hypervisor should just be VMware ESX, VMware vCenter, and KVM, Ovirt on Red Hat. So we can separate all of these from each other and for the professional and production environments. So there's a key benefits of Docker containers. There is a speed, no OS to boot, applications online in seconds, portability, less dependencies between process layers, ability to move between infrastructure. So you can run a container in this server and take it, save it, and run it in another server without any issue on dependencies and libraries. And efficiency, of course, less OS overhead and improved VM density. What is Docker? Docker is a platform for developing, shipping, and running applications using container technology. Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Containers allow a developer to package up an application with all of the parts it needs, such as libraries and other dependencies, and ship it all out as one package. There is a Docker history, and we need to know about containers and Docker history. So there, in the 2004, there was Solaris containers introduced from Zunt technology. And of course, after that, 2008, Linux containers, LXC 1.0 introduced. In the 2013, Solomon Hykes started Docker as an internal project within .cloud. And in March of 2013, Docker released to open source. In February of 2016, Docker introduced first commercial product now called Docker Enterprise Edition. And today we have open source community include more than 3,000 contributors, and of course, more than 40,000 stars. For Docker family tree, we just had two products, Docker Enterprise Edition and Docker Community Edition. Docker Enterprise Edition is subscription-based, commercially supported products for delivering a secure software supply chain. And of course, Docker Community Edition is a free, community-supported product for delivering a container solution. So intended for software development and test environments. And as you can see here, we just had a Docker Hub. This is a Docker registry or Docker Hub, and you can pull or download a Docker image from Docker Hub, run it in a container on Docker engine, and you can stop a container and delete a container. So it's a container cycle for Docker engine. So Thank you so much for watching this video.